Midpoint theorem. The line segment joining the midpoints of any two sides of a triangle is parallel to third side and equal to half of it. Now see here, a line in a triangle. So in a triangle, I'll take triangle ABC. In triangle ABC, okay, the line segment joining the midpoints. Now if we'll take two midpoints, D and E. D and E are midpoints. So here E. D and E are midpoints of AB and AC respectively. So here see, given triangle ABC, AD equals DB is given and AE equals AC also given. Now to prove, we need to prove a line segment joining the midpoint of two sides is parallel to third side. I need to prove DE is parallel to BC and equal to half of it, and DE is half of BC. This I need to prove. Now see, for this construction is draw CF parallel to BA. Draw CF parallel to BA to meet DE, this is CF, to meet DE produced at F. DE produced at F. So this is parallel to this BA. So here this line is parallel to this line, this total line. Here AB is parallel to now CF because of construction. Now proof. Now see, proof how to do it. Like first here in this we need to prove these two triangles congruent. This one AED and CEF. First I'll prove these two triangles congruent. Then by CPCT I'll take AD is equal to CF, but AD is already is equal to DB. See, AD is equal to CF by CPCT I'll tell after proving these two triangles congruent, and AD is equal to DB already given. So from these two I can conclude that DB equals CF and DB is parallel to CF. So if we'll join the endpoints, we'll get a parallelogram. Now proofs here. I'll take triangle AED and triangle CEF. Triangle CEF. Now in this, first one, see, angle 1 equals angle 2. Angle 1 equals angle 2. Interior alternate angles. Next, AE equals EC given, and next angle 3 equals angle 4. Angle 3 equals angle 4, vertically opposite angles. Vertically opposite angles. Now see, two triangles are congruent. Triangle AED is congruent to triangle CEF. By angle, you got angle side angle. By ASA congruency. ASA congruency. Now, so as these two triangles are congruent, I can tell AD equals CF, corresponding parts of congruent triangles. And I'll write one more statement which I'll use later. DE equals EF. DE equals EF. Here DE equals EF. Reason also CP, CT, corresponding parts of congruent triangles. Now, see here, I'll use this one first. Now, AD equals CF. AD equals CF. Just now we wrote because of CP, CT. But AD equals DB. AD equals DB given. So this is if I'll consider it as equation 1, and this if I'll consider it as equation 2. So from 1 and 2, from equation 1 and equation 2, see AD and AD. So we can write clearly CF equals BD. CF equals BD. And CF is already parallel to BD. So if we'll join if two lines are equal and parallel, so if you'll join the endpoints, you'll get a parallelogram. So here two lines are equal and parallel. Therefore, BCFD is a parallelogram. BCFD is a parallelogram. So now see, BCFD as it is a parallelogram, so I can say DF is parallel to BC. Therefore, I can say opposite sides are parallel. So DE is a part of DF. So DE is parallel to BC. This is the first proof. This is the first one. Now, we need to prove DE is half of BC. So see, DF is equal to BC. So this is another part. DF is equal to BC because opposite sides of a parallelogram. Opposite sides of a parallelogram. But DF you can write as DE plus EF equals BC. DE plus EF equals BC. So you can write DE plus DE, DE plus DE, because there is EF equals DE here. EF equals DE. We wrote already because of CPCT. So 2DE 2 times DE equals BC. So DE equals BC by 2. So DE is half of BC. This is second proof. So DE is parallel to BC and DE is half of BC. This is midpoint theorem.